So this is the assignment which we will be attempting now. And it's basically a very small, just 4 columns, a few beams, and some handrails around them, and some splice points as well. So you can see that if I zoom in over there, you can see that there are handrails, and the handrail posts are connected to the floor beams like that. And then there are some splice points. So you've got splice points over here in the beams, and over here and over here. So basically on these 2 beams only. The other 2 beams don't have splices. And because of these, and when the assignment is basically about creating these checkered plates in these areas over here, which the floor would need. So there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 checkered plates will be created along with their stiffeners. So the checkered plates are very thin, as you know, so they need stiffening usually under them. So these stiffeners under them are given as angles, CA 40 by 40 by 2.5, and we can zoom in over here to see how the angles are welded under the checkered plate at certain distances. Those distances are given over here for each individual. Full dimensioning of the checkered plate is not given, but the idea is that we can see from the notes over here as well that so the splice points are located 750 millimeters from the columns. That's shown over here. The middle of the splice point is 750, and the posts of the handrail are the first and the last post are 350 millimeters from the columns, and then they're equally divided into basically 1, 2, 3, 4, 5 more posts in the middle. So that's the dimensioning of the posts, and the checkered plates need to be cut around the obstacles. These obstacles include end plates of the handrail posts as well as the splice flange plates. So as you can see over here, the individual checkered plates have been cut out. So this long cut is around the splice, and these shorter cuts are around the handrail posts wherever they come. And the tolerance is about 5 millimeters. You need to clear the obstacle by 5 millimeters. You need to go around it. And they're also cut around. So the 4 columns over here, these 2, if you notice from the 3D view over here, these 2 columns end at the floor level, whereas these 2 columns at the back, they're continuing for whatever reason. But that creates a difference because the checkered plate over here also needs to be cut around the column, and also needs to be cut around the column over here. But on the other side, because the columns are not continuing, therefore the checkered plate is just basically capping the column over here and over here. So if you zoom in over here, we see the 5 millimeter offsets given. These cutouts need to be offsetted by 5 millimeters. And in areas like this area where the checkered plates are only sitting on top of the beams, they have to be separated from each other as well, like this point and this point. And that is also given as detail 2 over here, that the checkered plates are offsetted 5 millimeters from the axis of the beam. So you have enough space to weld them to the top of the beam. That's basically the assignment. The assignment is to basically create the checkered plates with their stiffeners. But to do this assignment, first of all, you will need to create the columns and the beams in just a few minutes, and the handrails. We'll be using the handrail macro. We won't be explaining the handrail macro over here, but we'll just quickly use the handrail macro to create these 4 handrails. And then we'll use the splice macro to create these 4 splices. And then basically the assignment will be about how to create these checkered plates. So let's just begin by entering that structure very quickly. We just need 4 columns in the corners, like that. And right click to finish. We need the beams. The beams can be IPE 300. The columns were HEA 300. Let's just see what the profiles are. So IP 300, that's fine. These ones are HEA 300. Then let's go back to the drawing to quickly see. So there's a beam in the middle. This one is continuous. These ones, no, the middle one is continuous. So along the X direction, this one is continuous, and this one breaks into two. So we just go back and we create a beam from here to here, and then from here to here, and from here to here, and then there's another beam from here to here, from there to there. So we just do like that, and there's another one like that. Let's go back to the drawing. This one going over here like that, and then they're basically at 45-degree angles, like that and like that. So that basically finishes off the floor beams for us, and now we can quickly create the splice points and the handrails around it. But before we do that, let's just extend these columns as well, because these two columns were going to be, just make them 7 meters if you want. The other ones were 5 meters. So yeah, this is what it's supposed to look like. So now we see that these the splice points on these IPE 300 beams on the left and right are given as at a distance of 750 millimeters from the center of the column. So what we can do is we can select this, go right click and say break frame, and we can hover over this point and say dy minus 750, like that, so that we have a broken frame over there. Then we can select this part and hover over this point now and say dy 750, like that. So we have the two beams broken. We can do the same for this one, hover over this point, say dy 750, and hover over this point and say dy minus 750, like that, so that we have the 4 splice points ready. Now that we have the splice points ready, we can just go to the splice connections over here and very quickly just make those splice connections like that. This is all just preparatory work for the main assignment. So we've got the splices ready now, and now we can move on to quickly create the handrails. Now, under the ancillary steelwork, we have the handrail macro over here. So let's first quickly use it to create the handrails on all 4 sides, and then we'll modify them according to our requirements. So select that. To make this one, since there are 3 beams over here, because of the splices, we'll select this beam, and then we'll select the middle beam, and we'll select the last part as well. Then we'll right click, and then we'll basically select the start point and make sure the red snap is lighting up so that you have the correct points. Then for this one, you just select this one. There's only 1 beam, right click, make sure the red one is lighting up, make sure the red one is lighting up on the other direction as well. For this one, you will need to select all 3 like that, right click, select that point, and for the last one, once again, right click, make sure you have the red thing snapping like that, and you have the handrails entered. Now let's just modify one of these. So we select any member of this handrail, press M to select the macro, and press enter to open up the thing. We have this requirement of the first post and the last post as 350. So I'll just enter those. This interpost distance, this is a guideline distance because it's going to try to equally divide. So if I put 1000 over there, it's just going to try to equally divide, and obviously it will be slightly less than 1000. It's probably going to be the same as the other example. This one, it's not really part of the assignment, but to just pull it back a little so that it doesn't hit the column, make it 140. For the post settings, we'll use the pipe, and we'll bring it to the middle so that it's sitting on top of the beam. That will be one change. For the end plate, because there's going to be an end plate connection at the end of them, I'm just giving these numbers because they're the same as the other example, so that it turns out to be you have the same model. So we have that, and we want the end rail to be we want these elbows and everything. So we turn on these. This is not a video about how to use the handrail macro. You can see another video on that, but basically just to create something similar. So these settings, the post in the middle, the pipe, the end plate dimensions, and the handrail. So that should basically do it. Let's see. Yeah, so that's basically my the kind of handrail I want over there. It's sitting on the middle of the beam. It's spaced by around whatever 833, I think, right now. You can probably see that now. If you measure the distance from here to here, it's roughly about 800. Yeah, I'm not snapping to the right point, but it should be the same. Now, once I have that, I can turn on my macro symbols over here. This is my macro which I've modified. What I can do is I can just go and select like that and go to my macros, and it tells me that you've got 4 handrail macros and 4 splice connections. I want to modify the handrail macros, so I select those 4. Let's turn this off and right click and say match elements to this one, which I just modified, and all the other macros will now be modified accordingly. So this I basically just set up the structure the way it was meant to be in the example, and basically the assignment will start from this point. Okay, so there's one thing which I forgot to do, and that is actually didn't create the end plate connection for the post. So I can just select the post again, press M and enter. And if I go to my post settings, there's a default is to connect with the directly welded, and I don't want that. So I'll turn it off. And when you turn it off, then it goes to the other options. So there you go. Once I turn that off, then the actual end plates are also created. And once again, I can select the whole thing, go like that, go to macros, select the handrail macros, and make them all match this one. So we have the end plates on all sides. Now, the reason why this topic is important is because checkered plates, as you can see over here, if I were to zoom in, you can see that they're quite involved. All these cutouts, and they will require you to create dozens of points and all the offsetting by 5 millimeters or some number. This would make it really time consuming for the user. And so we need a way to actually create them with a lot of ease. So you can see from this picture over here that it's not easy to make. It's easy to make as far as the basic process is concerned, but it's time consuming. So let's go back to the model and we'll discuss. So there's a concept in COMOSYS which is called floors. So you see on the left hand side, it's called floors, and this one is used for primarily for entering loads in the building. So what the floor will do is it will automatically find. So let me go back to the drawing. If you remember, there were 13 checkered plates. There was this one, there was this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. And if you notice, all of them are the areas between the beams, right? All of them are, let's go to the model. See, this one lies between this beam and that beam and that beam, because they have a splice point over there, and that one. So 1, 2, 3, 4, 5 beams make this or kind of provide the circumference for this checkered plate. Similarly, for this one, it's this the one I've selected, this one and this one. These 3 provide the circumference for that checkered plate. Basically, the beams will provide and the connectivity between the beams will provide information on that. And the same connectivity is used for applying loads to the floor. And that's for that we have this concept of floors in COMOSYS. But we use the same concept to actually create the checkered plates as well, or the gratings for that matter. So how does it work? What you do is you come to the floors and you right click and you say create floor. When you do that, it asks for a name, and you can, since this is level 5000, you can give it a name of plus 5000 level, any name. Basically, this is just a name. Give it that name, and once you do that, then under the floor you get this new floor. Right now, there's nothing in it. It's just a name. What you can do with it is you can select it and right click and say find polygons. And when you do that, what that means is it will look at the 5000, it will look at some level, which it's going to ask for in a second. And it's going to try and find all these areas, all these 13 areas where theoretically loads can be applied on the structure. But we'll use the same concept for checkered plates as well. So it says you want to find the polygons of plus 5000 level. This name doesn't mean anything. This could be any name. When I say yes, it's going to ask for a Z level. And this Z level, because we're working in this view, this Z level will be in reference to the coordinate system of that view. So since that view is at the 0 level, I'm going to say 5000 from that level. When I do that, you see immediately it creates certain polygons. These are not checkered plates. These are just polygons which you can now use because COMOSYS is also a software for doing analysis and design. I can actually create load cases and use these polygons to create loads on. So this one, for example, can create loads on this beam over there, on this beam over there, on this one over there, the one basically which are surrounding this polygon, and so on and so forth. So the primary purpose of these yellow polygons or orangish polygons is to create floors. But like I said, we can also use them to create checkered plates. Now, how you do that is you just select the whole thing. You select those. Basically, you only need to select the polygons. So you can either do the whole selection or just select the polygons. If you come over here under the other section, you will see floor. And when I do that, only those polygons will be selected. And if you notice, their count is 13. They're basically the same shapes as the checkered plates. The only difference being they do not have any of the cutouts. They're just basically they have information about the beam connectivity, how the beams are connected around those, but they have no information about these plates and the splice plates and the post end connections and all that. But when I select these polygons, if I come to the ancillary steelwork on the right hand side, and I just click on it, once the polygons are selected, all I need to do is just click on it. There are certain defaults. If you want, you can first click on the shift key and open it and make some changes to the settings. That's also possible. Or you can just click on it with the default settings. And I'm going to just click on it now, like that. And when I click on it, you see that it has done something. It has actually created my checkered plates. You can see they have been cut out with certain offsets around those obstacles, around the flange plates of the splice connection, once again around that. And there are 13 of those. Just to make it clear, let me turn off the visibility of the polygons now because their work is done. So let me go in there and turn off the visibility of the polygons like that, so that I can see them, see this clearly. But if you notice, basically this assignment is over. Every one of those, let's just say show only, every one of those checkered plates is now ready, and we can actually just do numbering and create the drawings if you wanted to. Let's look at this one. Say show only. You can see that this is just like let's turn on the, and you can also see that it has cut out around the column as well, and it has also realized that this column is not continuing, so there's no need to cut this one out. So it's just left it like that. Just look at it from the top. And let me, in fact, let's see what kind of usage it has. It has, let's see where we can find the The usage is checkered plate over here. So these plates have been given a usage. If I were to turn, and if I turn on, press on Alt D, you will see that it has also provided the stiffeners at the under them. And of course, there are settings for each one of these. If we go inside, if you double click on any one of these macros, you can control what kind of a stiffener you want, whether you want an angle profile or you want a plate. You can put in the distance between the stiffeners if you want. You can actually make it design those or kind of a rough design by giving the area load on that checkered plate, kind of a uniform load, if you will, that kind of a design. But of course, you need to check it more with a proper design, but this will give you a preliminary kind of a design. You can give those offsets of 5 millimeters, which are mentioned in the assignment over here, the plate offsets, the frame offsets around the column, the floor offsets, column offsets separately. The floor offsets would be in between the checkered plates, between the beams over there. So all that, if you notice, it's created 1, 2, 3, 4, 5. It's actually created 19 macros, one each for each checkered plate. If I were to select like that, press enter and click on the macros, you now have 13 floor macros as well. You had 4 handrail macros to begin with, 4 splice, and we've got 13 floor macros. I can easily select those, and I can click on enter. And from here, I can do multiple modification if I wanted to. But my job with this assignment is primarily done. If you open the drawing, you will see that all these checkered plates, which were in the drawing, have been created automatically by using this concept of floors. Now let's give a little bit of extra information about the inside workings of this macro. So let's just select one of these checkered plates, click on M, which will select the macro symbol, enter, open it. And you see that there are certain parameters over here. Let's zoom in over here. So this one, which says the plate offset, is basically right now the default is 5, I think. But if I made it 20, for example, if I said apply, you'll see that this around all the plates, wherever it finds plates along the beams, which as obstacles, it will offset them by this number. So that's basically the job of this offset, the plate offset. The second offset, which is useful, let's bring it back to 5. The second offset, which is useful, is the column offset. So if I put this one to be, the default is 20 in this case. If I put this to be 5, then if I say apply, around the column, the cutout becomes 5 millimeters offsetted. So that's the column offset. Whatever the size of the column is, depending on that, it will be used. And related to that is this frame height limit, which is basically a limit for the column size. So the default is 300. What it's saying is that if the column size is less than or equal to 300, then you just cut it like this. So if you notice, there's a little hole left over here from which something can fall down. That would depend on from case to case. But if you wanted to actually go around this, you could reduce the frame height limit to 200, for example, because this column is 300. And if I do that, then it's going to do a cut right around the column like that. So the shape of the checkered plate would change. Let's pull this back as well. The floor offsets, let's put it back like that. The floor offsets would be the offsets between checkered plates around the axes where two checkered plates are lying on top of a beam. If I put this one to be 22 millimeters, let's say, then this one will open between that one. Obviously, I'm only applying it to this macro now, so it's only in one direction. The total being 22, half of that would be 11. That would probably make the change like that. So there's one, that's the one we can use. The column offset, the frame offset. Frame would be if there were frames coming out of here. Let me talk about, so over here you see whether the stiffeners you want under it are angles or plates. If you want, you can convert them to plates, and then there will be other information on the other tab. But over here you also have the distance between the stiffeners. So you can enter some distance between them. This is also part of our input, if you remember. We have inputted the distances between the stiffeners like that. So those can be inputted from that setting over there. And there's something called bending switches. Now, what are these bending switches? The bending switches, basically a bending switch of 0 means no bending, and a bending switch of 1 means bend. So this is a rectangular plate with lots of cutouts, but primarily it's a rectangular plate. So there are 4 sides primarily, and all sides have the cutouts. But since there are 4 sides, saying 0 means don't bend, and saying 1 means bend. So usually it's a bit of a hit and miss, trial and error, but you can find them quickly. So if I was to just say 1 and then 0, it would mean bend the first edge, and then for the remaining, just 0 means, actually I could have said 0, 0, 0. That's the same as, that's saying bend the first edge and leave the remaining 3 edges unbent. But this is the same as entering it like this. So the last digit is used for the remaining edges. So 1, 0 would mean bend the first edge. So if I do that and say apply, you see that this is the first edge, this one, and it basically creates a bend for that edge. Sometimes when you're pouring concrete or for some other reason, you want these edges to be bent as well, for things not to fall off. For example, over here, you want this opening to be closed or something like that. So when you put 1, 0, the first edge will be bent. Now, if you want to know whether this one is the second one or this one is the second one, the way to do that would be say 1, 1 and 0, so you know which one is the second one. So okay, this is 1, this is the second one, and then there's that. If you wanted the first 2 to be left untouched, you would say 0, 0, and then 1, because now you know this is the third one, and then 0 for the last one as well, like that. Or maybe you would say 0 and 1, so that those 2 edges of the building will get bent. So let's zoom in and see. It'll once again go around those obstacles like that, as you can see. So very convenient, very easy to use. Let's go back in. You can turn off these switches and it'll come back to the normal state. On the other side, on this detail tab, you can put in the stiffener depths if you're using a plate. You can give the offsets between the stiffeners. You can give the stiffeners a thickness. If you're using the angle, then of course it's the angle profile. But if you're using the plates, then you can give them the stiffener thicknesses, the welding material, etc. Obviously there's a weld between the angles and the checkered plate, so you can provide that information on that weld as well. So this using this floor-based macro rather. So the way it works is you first create the floors, you select the floors, and then you just click on this. When you do that, then basically it creates those checkered plates with a single click. Now, one final piece of information about this macro is that, let's select it, press M and enter, is that using the same macro with which we created checkered plates using the floors, let's not forget that, we can go over here to the floor plate type, and we can choose, instead of checkered plates, we can choose grating. And when we choose grating, you can choose the type of grating. This is linked to a file where you can input all your gratings. You can also link the checkered plates to a file as well. So if I just select the grating over there and say apply, then instead of the checkered plates, the same command can produce a grating. This time, if you see the symbol also changes, but it's doing the cutouts around those plates as well. You just select the grating type, and suddenly you have 12 checkered plates, and this one is a grating. Obviously, you're not going to do it in real life like that. But basically, the point being that the same command will allow you, if I wanted to do a multiple selection, if I just selected all of them, go to the macros and go to my 13 floor macros. And if I just said make them all gratings, I could just say match elements to this one, and all of them would be converted to gratings. Now, I think I didn't select them. Hold on. So if I were to just go and select them again, let me just do a multiple selection over here. Maybe the match elements is not implemented for this. If I just double click on this one, for example, yeah, that's like that. And if I convert these to grating from here and say, okay, close and close, yeah, all of them are now turned into gratings. Yeah, there we go. So very quick and very easy way. Otherwise, normally, just imagine if you were going to enter all these offsets, 5 millimeters on every side, create all those points or use DXTY, it would be pretty time consuming. And then the stiffeners under them. So with a single click, we've managed to finish off this assignment.